So we are going to go over the FRQ 2019 release by the College Board. It's the light board class, but in this case I modified it to be a one-dimensional array rather than the two-dimensional array that they have released. So you want to kind of read through this carefully. The lightboard class models a strip display of lights, where each light is either on or off, but represented by a Boolean value. Therefore, the light on the board, if it's true, that means that's going to be on. If it's false, it's going to be off. So you are going to be able to implement part A, which will be your constructor, and part B, which will be the method evaluate light. Now within your constructor, notice that in this case we only have they declare your array of Boolean and they name it lights, and you have to be able to implement your constructor in this area. Your constructor is going to take in a parameter, an integer named num, and that'll be the length of the number of elements of the array. So that'll be the length of the array. And you want it to be a 40% probability that's going to be set to on. So let's go over it, read, and that's basically what it says in here. So therefore, notice one of the key things that you have to remember is that they declare your array of Boolean called lights, but they haven't initialized it. You need to be able to initialize that in your constructor. So therefore, we are going to say lights equal is in a new array of Boolean, and how big does it need to be? It needs to be num. So therefore, in this case, you initialize your array of Booleans, and remember, one of the key things that you need to remember, the initializes it to false. Now, what we need to go through, we need to be able to go through each of the items in your array and set 40% of them to on. So see if you can figure that out. I'll pause it. You'll need to go through a for loop. So you're going to need a for loop. You need to be able to find a way that you're going to place 40% of them to true, to on. See if you can figure that out, pause it, and then we'll continue. So did you guys do a for loop or a for each loop? It's up to you guys, you get to decide. So in this case, I'm just going to do a for loop. So int I equal to 0 until while I is less than the length of the array. So be what's the name of the array? Lights, that length or that size, that length. Do I need parentheses or not? No, whenever you see an array, it'll be just lights. Now, in this case, we already know that it's actually num. So you can do this, or you can actually just do num, because that is the length of the array. Either one will be fine for this exercise. I++. So remember that in this case, you can have num, or you can have lights that length. In this case, I'll just leave it as num. And now we are going to go through and initialize only if it's about 40% of them. So we are going to do an if statement, and we're going to do math random. Now remember that whenever we do math random, it's going to create a double from 0 to 0.9999. So therefore, if it's less than 0.40, if that's true, then we want to be able to place the lights at that specific index to be true. Now there's a shorter way of doing this. Some of you guys might have done it. It says int rand number. Some of you guys might have done it in this form. Which is fine, but then this will be a little much more easier to read on this for myself. And it actually, there's another way that you can actually simplify further, but for our purposes, this should be sufficient. And notice I only have one statement in my for loop, so therefore I do not need my braces. And that's it. That's all we're doing for the constructor. So therefore, it's going to go through each item in your array, and if it's less than 40%, then it's going to set it to true. So that should be able to set about 40% of the lights to be true. And now your second part is to be able to evaluate. We're going to go through and implement this method here. Write method evaluate light, which computes and returns the status of a light based on the following rules. If the light's on, you're going to return false if the number of lights that are on is even, including the number of the current light. If the light's off, you're going to return true if the number of lights that are on is divisible by 3. Otherwise, you're going to return the lights as current status. So therefore, if it's on, you're going to return false only if the number of lights that are on is even. Otherwise, you're going to return true, which is on. If it's off, you're going to return the opposite, true, only if the number of lights that are on is divisible by 3. Otherwise, you're going to return false, which is off. So for example, suppose the light board that's same equal to new light board creates a new light board with the initial state shown below. So in this case, we are creating a new light board with 7 lights on the strip. And therefore, whenever we call evaluate light of index 0, which is true, which will be on, it's going to return false since the number of lights is even that are on. So we have 2, 3, 4 lights are on, which is even. So therefore, we're going to return false. In the following case, we have a light board with 10 lights. We're going to evaluate index 5, which is also true, same thing as this example. But now in this case, we have 1, 2, 3, 4, 5, which is not even. So therefore, it's going to return the value of the light, which is true. And on example number 4, it's going to create a light of 8, a strip of lights of 8. So we have 8. It's going to evaluate the light at 4, which is false. So therefore, this is going to apply. It's going to return true if the number of lights that are on is divisible by 3. So in this case, we have 1, 2, 3. So therefore, it is divisible by 3. So therefore, it's going to return true. And on the last one, a light board of 9 lights is going to evaluate, again, one that's false. And it's going to return true if the number of lights are divisible by 3. In this case, the lights are 1, 2, 3, 4, 5. It's not divisible by 3, so therefore it's going to return the light itself, which is false. It sounds a little more complicated than it is. So let's just go through and implement the actual rules. First, we want to be able to find a counter because we want to be able to count how many lights are on. So we're going to declare and initialize our counter. So we declare initialize it. And now we want to be able to count how many lights are on. So do you guys want to do a for each loop or a for loop? Since I need to go through all the lights, I'm just going to do a for each loop. So remember, for each loop is what type of um, what is the type of objects that it's in the array? What is the type? In this case, it's a boolean. We're going to give it an easy name, A. And what is the name of the array? In this case, it's called lights. And now we're just going to say if A is true. But in this case, it's a boolean, so we can just say if A, which means that if it's true, then we're going to increase our counter plus plus. We're going to count them. Remember, they could also have done this. It'll be the same thing. That's going to count how many lights are on the strip. And now we need to go through the rules and make those two if statements. And I'm going to do it as two separate if statements. You might be able to combine as a if else statement. You might have done it slightly different, which is fine. But I think this will be much easier for everybody to understand. So we're going to go through and say, this is the light that you're going to be analyzing. Same way that this was the fifth light or the index at 0. So therefore, if lights at the specific index that they give you, let me make an extra space in here. Lights at light number, if it's on, and the number of lights it's even, they're on, so that's our counter. How do I see if it's even? So be mod 2 equal to 0. The remainder, whenever you divide by 2 is 0, then it's going to return false. Now in this case, I can go back and simplify. I can actually get rid of this part. If it's true, it'll be exactly the same, just like we talked about it above. But some of you guys might find it easier to do it this way. Either one is fine. If it's false, that'll be on the second option. So if it's off, then we're going to return true if the number of lights that are on, which is your counter, is divisible by 3. So therefore, if your counter is divisible by 3, once again, we can actually change, and then we're going to return, I'll go back and return true if that's the case. So if it's true, if it's on, and if it's divisible by 2, then we're going to return false. If it's false and it's divisible by 3, we're going to return true. Otherwise, we're going to return the status of the light, which will be lights, light number. But remember that in this case, if we want to be able to change this to an easier manner, we can actually have done it as follows. And there might be a simpler, more simplified version. But for now, I'm going to leave it as this, which might make it much easier for some of you guys. That's it. Let's go and run it. Let's see if I have any errors. It doesn't want to run, so let me just go and reload it. So that is the code that we implemented. And let's compare it to the actual output that's supposed to be. And notice sometimes this might give you something a little smaller. Let me run it again and see if it gets to me. Just random numbers. not always. Okay, there you go. So it gives me 39, 39. Perfect. False, true, true, false. And then submit it. If by any chance you get in, the part B doesn't pass, submit it again and see if it does it the second time around. So that is the solution for the light board. Have a great day and email me if you have any questions. I'll see you guys next time.